Okay, in this video we're going to talk about angles and how you can measure them, how you can name them, and not all the properties. We're only learning some of the properties of angles. So an angle, usually angles are measured in degrees. And the symbol for degrees is that little circle that's in like the top right-hand corner. We have three different types of angles that we're going to talk about in this class. The first kind of angle is going to be the right angle, and this should all be something you've seen as you are making your geometry book. A right angle is an angle that has a 90-degree measurement. Okay, and so we usually see it and know it because it has this little box that shows it's a right angle. Okay, we have an acute angle. An acute angle is an angle that is smaller than a 90-degree angle. Okay, so it's an angle less than 90 degrees. Okay, and then the opposite of that would be an obtuse angle. An obtuse angle is an angle that is more than 90 degrees, but it's less than 180 degrees. So more than 90 degrees and less than 180 degrees. Okay, so the angle measure of a straight line. Okay, so the angle measure from here over to here. Okay, that is 180 degrees. The angle measure of a circle. So if I had like a circle and I started right here and I went all the way around and came back to here, that is 360 degrees. Okay. So at this point, if you were in class, we would practice measuring angles with a protractor. You probably, I'm assuming you don't have a protractor at home. So let me just show you how we would have measured them in class, practicing using a protractor, and hopefully that will be sufficient. So if I wanted to measure this angle right here, the way I measured that angle with a protractor, I have two different protractors I'm going to show you with. The first one looks like this. It's your normal protractor. So notice there's a set of numbers on the bottom and the set of numbers on top. Those are based on which way your angle is opening, if it opens to the left or if it opens to the right. Okay, this angle we're measuring right here, it opens to the right-hand side. So this opens to the right, so I'm going to use the lower scale, the numbers on the bottom. Okay, this little circle in the middle, that's where you put your where your two lines meet, the intersection of your two lines. And then the other thing, you see this line on the bottom of your protractor, you have to line that up with your bottom line here. So make your intersection be in the middle of that circle, make your bottom lines line up, and from there you can see it's one of these two answers. It's the bottom number because this is an acute angle smaller than 90, so I need a smaller number. So it looks like it's a little bit less than 40 degrees, probably 39 degrees. So I would probably say that was 39 degrees. Okay, if you wanted to measure this angle over here, we could measure it again with a protractor. So line it up. This time it's going to be the number on top, and the number on top looks like it's right in between 140 and 141. So I'd say it's 141 degrees. You could say 140.5 if you wanted to. Okay, and one thing I noticed, these two angles should add up to be 180 degrees because they're on a straight line, and we'll talk about that a little bit more in a minute. Those are called supplementary angles that add to be 180 degrees. Okay. I said I had two different protractors. That was the first one I was going to show you. I'm just going to show you this one. This one's a little bit smaller, and I could have not measured that other one as perfect as I should have. So yeah, 40 degrees, 140 degrees. So same thing, just two different looks to it. Same idea. This one's a little bit smaller. Okay, so supplementary angles are two or more angles that add to be 180 degrees. We also have another one of those. They're called complementary angles. So complementary angles are angles that add up to be 90 degrees. So let me see if I can draw one here. It's not going to be perfect by any means, but let's see. Let's see what I can do. Okay, so let's see. We're going to say this is a 90-degree angle. It's not too bad. It could be worse. And then let me draw. Okay, so here's an angle right here. Ignore that part. And here's an angle right here. Let's measure those two angles. So for the first one, I'm doing this bottom angle right here. To measure that one, let me make my lines intersect a little better. Line up your intersection, line up your bottom line as good as you can. And it looks like that first, if you can see it. I'm using my bottom number because this is an angle that opens to the right, and it looks like it's about right at 65 degrees. Okay, so this bottom angle is 65 degrees. If I wanted to measure this one, I would now need to kind of turn my paper sideways a little bit, and that's my bottom line. Okay, because I'm starting from 0 again. So here's my paper. I'm sorry, here's my intersection. This one looks like it's about, let's see if I'm lined up super well. About 25, 26 degrees. Looks like it's about 26 degrees. So you could say 25 or 26 degrees. I'm going to say 25 degrees here because I know that these two angles need to add up to be 90 degrees if this is a right angle. Okay. The reason why it probably came out as 26 degrees is probably I didn't draw these lines perfectly perpendicular to make a 90-degree angle. But this is an example of complementary angles. Let me zoom back out now. Okay, so complementary angles are angles that add up to 90 degrees. Okay, and it could be more than two angles. I just drew two angles here. You could have 3 angles, 4 angles, 5 angles, however many, but all of them add up to be 90 degrees. Complementary is a right angle, supplementary is on a straight line. Okay. Okay, so let's talk about a few things about, let's see. Let's talk about triangles, angles within a triangle real fast, and then we have a few other things. Okay, so angles within a triangle, the angles add up to be 180 degrees. And if we were in class right now, I would do a little activity to prove this. I'm going to go ahead and do it anyways. Let me grab some scissors really fast. Give me like 10 seconds. Okay, sorry. So, if I had a triangle, so let me just cut a triangle out of this real fast. Okay, here's my triangle right here. So all my angles on my triangle are right here. This is an angle right here. This is an angle right here. This is an angle right here. If we were in class right now, I would make everybody do this, and I'd say some people make a big one, some people make a small triangle. Like everybody make different triangles. Do a right triangle, do an obtuse triangle, and a acute triangle, whatever. And then we would color all the angles, and then we're going to cut off our angles from our triangle. And kind of one way to show that the angles in a triangle add up to be 180 degrees. So because of that, we can find a few different things. So real fast, the angles, these are the interior angles, the angles inside a triangle add up to be 180 degrees. So a quick little example, if I had some triangle and I knew this was a, let's say this is a 105 degree angle and this is a 35 degree angle, and we're looking for this angle over here. Well, those are all three interior angles, so I know 105 plus 35 plus, I don't know, equals 180 degrees. And then you can do a little math to figure that out. So 105 plus 35 is 140 degrees. And then when I subtract 140 degrees, I get x equals 40 degrees. So that angle is 40 degrees. Okay. Something else that's super helpful to know about angles of triangle are the exterior angles. Nope, that's not how you spell it. Exterior. Okay, so one thing we know about the exterior angles is, I'll draw a picture of this in just a second, outside angle. Okay, so an exterior angle is an outside angle formed by extending a side of the triangle. So for example, if I had this triangle that looked like this, we could call this inside angle, this interior angle A, this interior angle B, this interior angle C. I have exterior angles also. If I extend this line, this side of the triangle, that gives me a new angle right there. We're going to call that, we do this with a different color actually, we're going to call that D. Okay, if I extend this side of the triangle, I get this new angle up here. We're going to call that E. If I extend this side of the triangle, I get this new angle, and we're going to call this angle right here F. Okay, so those are exterior angles. And we have this theorem that says the exterior angles, so the exterior angle equals the sum of the two non-adjacent, I'll talk about what that means in just a minute, adjacent, that's right next to D is A. So I'm not using that one. It's B plus C is what D equals. So angle D actually equals angle B plus C in this picture. If I wanted to find this angle E right here, angle E is not B, A plus C. The two angles that are not touching it. Angle F right here is not C, A plus B. Okay, so let's do an example of that. So if I had the problem, this triangle that looks like this, and I'm going to call this side, this angle A, this angle B, this angle inside, we're going to call this angle inside C, and this angle right here we're going to call D. Okay, we're going to say angle A is 50 degrees, angle B is 60 degrees, and I want you to find C and D. Well, it's really easy to find angle C because all three of these, and there's actually two ways you can find angle D. One way you could find angle D is now do 180 minus 70 because these are supplementary angles. Or if you didn't actually ever find angle C, it's easier to say, well, I know D is this one plus this one. Okay, so using the exterior angles, angle D equals angle A plus angle B. So angle D is 50 plus 60. So angle D is 110 degrees. Okay, so essentially that's pretty much everything you need to know about triangles. And the last two things we're going to talk about is, actually there's only one more because we already did supplementary and complementary. We're going to talk about vertical angles and then we're going to put it all together. Okay, so vertical angles. So vertical angles is, the technical definition is an angle pair formed by two intersecting lines. So basically, if I had two intersecting lines, an angle pair is the ones across from each other. So these are vertical angles. So like this one and this one are vertical angles. We also have this one, and this one are vertical angles. Okay, so the way I think about it is I just think about it angles across from each other. And the one thing we know about vertical angles, and you should be able to see it by the picture, is that vertical angles are congruent. So they have the same angle measure. Okay, so vertical angles are congruent. So if you knew this one was, I don't know, 75 degrees, that one's also 75 degrees. It's actually obtuse, the picture I drew. It'd be a number bigger than that. But if you know one, then you automatically know the other. Okay, so let's put this all together. We are going to do a problem. If I gave you two lines like this, we're going to say a line connecting it and a line going through it like this. Okay, so we have all these different angles here that's created by this picture. So this angle right here, I'm going to call it angle number 1. This angle up here is angle number 2. This one's number 3. This one's number 4. This one's number 5. Over here, I have this angle right here, number 6. I have this angle underneath it. I'm going to call that angle 7. And I'm going to call this one right here, like all the way around, is angle, I think I said that wrong. We're going to call that 8. We're going to call this one all the way around angle number 7. We're going to call this 9, we're going to call this 10, we're going to call this 11, and we're going to call this 12. Okay, so you cannot assume anything about an angle from a picture from the way it looks unless they tell you. I know that angle 7 is 180 degrees, right, because it's on a straight line. But angle 6 and angle 8 look like right angles, but I don't know that for a fact. You have to be told that, okay? Unless you were like using a protractor, but you're going to be told what all your angle measures are. So don't just assume that something looks like 90 degrees or looks like 30 degrees or whatever you want to say. Like, you have to actually do the problem to figure out what the angles are. So I'm going to tell you 3 angles. I'm going to tell you angle number 2 is 30 degrees. I'm going to tell you angle number 6 is 90 degrees. And I'm telling you angle number 12 is 30 degrees. Okay, so we were told those angles, we want to know all of them. So essentially, like, I want to know angle 1 equals what? Angle 2 equals what? Angle 3, angle 4, angle 5, angle 6, all the way to 12. 7, 8, 9, 10, 11, and 12. Oh, 12 equals that. Okay, let me zoom out a little bit so we can see it all at once. Okay, so they told me 3 angles. I can go and write those in. Angle 2 is 30 degrees. Angle 6 is 90 degrees. Angle 12 is 30 degrees. I'm going to go ahead and write those in. Okay, so angle 10 would be 150 degrees. Angle 11, same thing. These 2 are supplementary, or these 2 are supplementary, however you want to think about it. 180 minus 30 gives you 150, or also you know that 10 and 11 are vertical angles. If 10 is 150, 11 also has to be 150. Okay, so this one's also 150. Let me move up here. Angle 7, we already said it was 180 degrees because it's a line, so 180 degrees. If angle number 6 is 90 degrees, that means angle number 8 also has to be 90 degrees. And the reason why is because they are supplementary angles. They are on a straight line. 180 minus 90 would give you 90. Okay, so angle 8 would also be 90 degrees. Okay, so this is actually the hardest part of the problem over here. Angle number 2 is 30 degrees. So that means angle number 1, they are supplementary angles. They are on a straight line. So that tells me that they have to be, that 180 minus 30 is 150 degrees. So angle number 1 is 150 degrees. Angle number 2, if I try to find 3 and 1 are not vertical angles, okay? It's like number 1 and 3 plus 4 together are vertical angles, but 2 and 5 are vertical angles. So I know that angle number 5 is 30 degrees also. Okay, so now this is like the trickiest part, and some people have a hard time figuring this out. You may have already seen how to do it, but these two angles, I know they add up to be 150 because they're vertical angles with the number 1. So these two add up to be 150. Number 3 looks like a 90-degree angle, but I don't know that for a fact. Okay, nobody told me that. So technically this could be like 91 degrees, and this one could be 89 degrees, or 92, and 88, 93, 87, so on and so forth. So I need to figure out how to figure out the exact amount there. And the way that you figure that out is, if you'll notice, this is a triangle right here. If this is a triangle right here, okay, that tells me that these 3 angles add up to be 180. So to find angle 4, I need to do 180 minus 90 minus 30. And that gives me 60 degrees. So angle number 4 is 60 degrees. And the way I find angle number 3 now is, there's lots of different ways. You could say I know that 4 plus 3, angle 4 and 3 equals 150. So 150 minus 60 gives me 90. You could say all 3 of these are supplementary. They're all on a line, so they all add up to 180. 60 plus 30 is 90, so that means that one also has to be 90 degrees. Okay, so it did end up being 90 degrees, but you cannot just assume that, because on your test it's probably not going to be a 90-degree angle. It's probably going to be like 92 degrees or something. So make sure that you know how to find each angle using some type of property. Let me know if you have any questions about any of that.